We'll start by looking at the single-storey Mao model. This is a simple model and can be used wherever the height of rise of the spill plume is no more than 2 metres. That is to say that the vertical height from the spill edge to the base of the smoke layer has to be no more than 2 metres. The model is shown here. P is the perimeter of the fire in metres, and Z is the height from the fire base, that is usually the floor, to the base of the smoke layer, and it's measured in metres. So if we had a shopping mall with standard response sprinklers and a design height for the base of the smoke layer at 4 metres above the ground and the spill edge at 2.3 metres above the ground, we would be satisfied that we could use this model as 4 minus 2.3 equals 1.7 metres, and that's less than 2 metres. So we have a height of rise of only 1.7 metres. This model would give us the following for a prediction of the smoke entering the smoke layer. As you can see, m equals 0.38 p z raised to the power 3 over 2, and this equals, in this case, 0.38 times 12 times 4 raised to the power 3 over 2. Evaluating this gives us the result 36.5 kilograms per second. From this point on, we'd be looking at the temperature rise, the ventilation requirements, and so on, as we have done previously. Let's look at another example using this spill plume model to determine the mass flow rate of smoke entering the smoke layer. Let's say we've got a shopping mall with quick response sprinklers and a design height for the base of the smoke layer at 4.5 metres above the ground. Let's also assume that the height of rise is less than 2 metres. Using this model will give us m equals 0.38 times 9, that's the appropriate perimeter for a fire in a retail premises with quick response sprinklers, times 4.5, which is Z, the height of rise, or the clear layer height technically, raised to the power 3 over 2. Evaluating this gives us the result 32.6 kilograms per second. Now before we move on to the next model, you should try the exercises that relate to this model.